All right. So I believe I'm not correct. Didn't I give you a certain which numbers I wanted y'all to do? I think I did.
We did some on that day.
Yeah, we did some on that day. So I think the ones I have marked that we were going to work on were 5 and 9 and 13, 17, 19, 33, 35, 37, 45, 47. Okay, so I'm just going to write these up here. Okay? So, number 5, 9, 13, 17, 19, 33, 35. I would write these down unless you want to work all 50-something problems, which I thought you want to do that. I didn't want to do that. But I did. That's my job. All right, that takes us through 8.3. Actually, I only have one of 8.4. I have number 50 for 8.4 done. So let's go ahead and put these on here. We'll do 50. Actually, no, we're not going to do 50. Come back here. We're not going to do 50 because I want to do the odd numbered problem so you can look up the answers and double check your work. So we'll do 51.
Why does it jump?
Because I skipped and did 8.3 before we did 8.2 because we did torque before we did moment of inertia. So that's why it's a little bit out of order. 55, 57, 58. Oh, no, that's even number. There we go. All right, so those are the ones we want to make sure that we are able to do. All right, so which ones where did we stop off? What was the last one we did?
Number 9.
17? 9, 17? I never did 9.
I thought it was the last one. 9. Or at least I don't have it.
All right, so, well, let's work 13 then. Or let me rephrase that. Y'all work 13, then we'll go over it. Okay? So y'all work 13. In 13, we are looking for angular acceleration. We're looking for angular acceleration given angular velocity, and I think that's all we're given.
What page is
Oh,
that?
this is just increasing.
275.
We did do this one.
We did do this.
We did do this one?
I guess I didn't write it
I
down.
don't know if we went over it, but I know we put the answer
Okay.
on that.
Well, if you didn't write it down, let's go ahead and write it down. Let's go ahead and give everybody time to work that one out. You are given angular velocity, you are given an angular acceleration, and you're basically just asked, is it increasing in its rotation or is it decreasing in its rotation? Is it speeding up or is it slowing down? Okay. So that one shouldn't take a whole lot. There's not any math involved with that. It's a little more conceptual. So. And just like with linear motion, those signs mean something. If it has a negative sign, and we're talking about negative angular acceleration, what would that negative sign be telling us? That's what you need to be thinking about to answer the question. So a few seconds and then we'll go over it.
275.
Uh-huh. So, 413, what is it doing? Is it increasing angular acceleration or decreasing? It is decreasing. And the problem doesn't ask you to explain that, it just says choose one. So, all right, so the next one we want to do is 17. Yes, I remember now. This is where we left off. Okay, so on 17, it's asking you to find the angular speed of the Earth as it orbits about the sun. Give your answers in radians per second. All right, so you need to remember that the Earth travels around the sun how many times in 1 year? 1. That's the definition of a year. So it makes 1 revolution, 1 orbit around the sun every year. But you need to remember, a year is not 365 days. We all assume it is. We think it is. But it's actually not exactly 365. Don't use that in your conversion. Use the fact that there are 52 weeks in a year and there are 7 days in a week. And then you're basically just changing revolutions per year to radians per second. Okay, so go ahead and set up that enormous unit multiplier because that's what it is. And that's what I want to see, a unit multiplier, not a bunch of multiplication and division. Okay?
Question.
Uh-huh.
For trying to find the speed, is that the thing where you have to use the velocity and the acceleration?
Which number are we looking at?
17.
You do not, you're just doing a unit multiplier. So this,
Oh, you're just changing.
yeah, you're just changing, you already have the speed, but it's in revolutions per year, which makes no sense to us. So we need to change it to radians per second. No, that's fine. Because, yeah, it is angular velocity. That is the revolutions per year, which we then need to switch. Okay. So it's not a new formula, it's just a changing of the units. All right, so like I said, make sure that we're setting up a unit multiplier. Otherwise, you're going to really get confused. Can I have your bell ringers? I want to pass yours with that. And I got yours. Just pass these to the end of the table. That's good. I only had 2.
That one right in your name.
That's all.
Do revolutions per year. How many revolutions are in 1? how many radians are in one revolution. I think we have that at the very beginning. Yeah, right. One revolution is 2 pi radians. 2 pi revolutions on the bottom, 2 pi radians on the top, and then you'll go from years to weeks. You look in the very beginning. Okay, you changed, okay, we need one unit multiplier to change both, so you're just changing, you're changing the time. We also need to change the revolutions to radians, and if you do it that way, it's still gonna confuse you because you're not gonna know which one do I divide and which one do I not divide. So that's what I'm saying, you got the unit multiplier for the time, but you can do them both at the same time in one unit multiplier, that's right. There you go, keep going with that, that's perfect.
So radians is 2 pi?
One radian, or one revolution is 2 pi radians. So there we go. There we go.
Or you just leave it as 2 pi?
Well, you're gonna multiply all that out and divide by all of this.
Yeah.
So since that's so long, I would put 2 pi on the top because all those are 1. And then I would multiply all of this out and put it on the bottom and then divide with my calculator and the pi button. I wouldn't round to 3.14, I would use the pi key. I don't know what the answer is, but all the orange was there.
So it was 2 weeks?
There's 52 weeks in a year. All right. So this is what your setup should look like. Okay. This is what's going to keep you from getting confused with a long problem like this. If you write out your steps, write out your unit multiplier. That's the point of using them, is because I can very easily see, all right, I got rid of my revolutions, my years, my weeks, my days, my hours, my minutes, and I'm left with radians over seconds, which is what I'm supposed to get. Then I multiply the top. 1 times 2 pi is just 2 pi for now. And then I multiply the bottom. I'm doing it separately since this is so big and so long. If I try to do it all in my calculator, I'm going to make a mistake. I'm going to hit the wrong key. I'm going to do something. So take the extra time and work it out, top and then bottom. So 1 times 1 is 1. 1 times 52 is 52. 52 times 7 times 24 times 60 times 60 is 3,144,9,600. And then since this is 2 pi and I want to get the most accurate answer possible, I'm not going to say 2 times 3.14 because we know pi is a never-ending number, right? So when we round it that way, we are not being very accurate. That's why we have a pi key on the calculator. So use your pi key. So 2 times, and then do the pi function on your calculator. And I usually that big long. Don't round it. Take that, and then hit your division symbol and put in your big number on the denominator. 3,144,9,600. 0. And that is equal to 2 times 10. Because I'm putting in scientific notation, I get a decimal number. I don't want to write all that out. So that's 1, 2, 3, 4, 5, 6, -7 radians per second. Now, some of you got 1.99. That's fine as long as your power of 10 is the same. It needs to be 10 times 10 to the -7. Okay, now, if you got 10 to the -6 or 10 to the -5, then something happened wrong and you need to go back and fix that. As long as you're not off by an order of, we call it an order of magnitude or power of 10, then you're going to be okay, within reason. But if you get 1.99 times 10 to the -5, something's wrong. You need to go back and fix it. So any questions on that one? All right. So let's take a look at the next one was 19. So let's do 19. Y'all are going to work it out, and then we'll go over it. So 19, propeller on a ship has an initial angular velocity of 5.1 radians per second and an angular acceleration of 1.6 radians per second squared. What is the angular velocity after 3 seconds? So you have an initial angular velocity, and you're looking for a final angular velocity. They give you angular acceleration, and they give you time. This is a plug and shove. So, remember that angular acceleration, just like regular acceleration, is change in velocity over change in time. Yes. And the change in is your final minus initial. So that's where you have 1, you have initial, you're looking for final. Can't add them, no. That's like adding seconds to the -1 and seconds to the -2. You can't add them. 1 squared. You're not going to be doing any add. So you're going to plug in. You're going to plug into this formula.
That's what I did.
Yeah.
I just added illegally.
Now, I would, if you rearrange this properly, you're going to wind up multiplying the change in time times acceleration, which will change your unit, which you're going to multiply seconds squared, seconds to the -2, times seconds, gives you seconds to the -1, you need, yeah, so you read your denominator first. And it's all done. Just like in regular old math. Okay, so you're plugging in, okay, so we do acceleration together. Okay, we're not gonna do acceleration divided by 5. You wanna plug in here. So acceleration is gonna be equal to your change in velocity. The omega f minus omega s over t. So you're actually gonna be multiplying this by t, not dividing by t.
Just, so this one's second squared, and this one's not squared. Does that matter at all?
Yes, because that's your acceleration. You've got a for both of these, those are not both a's. That's a velocity, that's an omega. This is your alpha. You're gonna plug into this equation, okay? So it's gonna be your 1.6 equals,
Oh, that's your, okay.
yeah, equals your two velocities, 5.1 minus what you're looking for minus 5.1, and all that is divided by time. Okay, no. It's not 5.1 either. Plug it in just like that. Unless you're gonna rearrange the equation first. You have to if you want to. But if you rearrange the equation first, then it's gonna be delta omega equals alpha times delta t. And then that would be 5 something minus 5.
I know this was big.
No, 5.1 is the omega. Right in there. Average angular velocity is 5.1. That's your omega.
Okay.
That's your W. That's not your alpha. Okay? Okay, so like I said, one of the reasons we want to do these practice problems is because we want to learn what these symbols stand for. You look at these formulas, we got alphas, we got omegas, we got all kinds of weird letters now, especially. Not just X's and Y's. So you need to know, for a test, I'll give you the equation. But me giving you the equation is not going to be of any help to you at all if you don't know what the symbol stands for. That I'm not telling you, okay? So, all right, continue working these. We will work some more tomorrow in class, but you need to be practicing these on your own and watch 8.4 Ed Puzzle.
If you would like to run for student council officers, and you are in grade 11 and 12,